The key objective of Data Core Systems is to build an automated machine learning platform, to bring the benefits of artificial intelligence and machine learning accessible to everyone. Empower business and individuals to develop their own ML solutions without the hassle of knowing complex algorithms. Understanding of complex models and algorithms, which needs to be regulated for optimal performance. Providing an easy and concise way to develop own AI and ML solutions. Cloud-based Python AutoML SDK can be integrated with leading standard AutoML providers in the industry, currently supporting Azure, Google, H2O.ai, and DCS AutoMLs. Writing Python code with Flask REST API for each step of the app for production, and a secure user interface using .NET Platform to make user easy to use. But why DCS AI AutoML? Gain confidence, as you can compare data accuracy from the different interfaces in one platform, ultimately helping you to reduce risk factors in prediction. You can get rid of the tedious tasks like testing different ML approaches on the same dataset to evaluate model performance. You can get an aggregate score inferred from the experiments on each ML procedures from different platforms. Essentially, to get the same benefit from the leading AutoML providers, like Azure, Google, H2O.ai, from a single Data Core AI/ML platform. Welcome to the world of artificial intelligence. Log into the application, Data Core Systems AI AutoML platform. After logging in, you will have standard AutoML interfaces, provided by 3 leading organizations, like Azure, Google, and H2O.ai. Additionally, you have the benefit of Data Core's customized AutoML service, as well as customized machine learning services, to analyze your data efficiently and effectively. To perform any complex use cases, which are not usually doable using AutoML, be it supervised or unsupervised, like churn analysis, customer behavior analysis, market basket analysis, and deep learning. Due to time constraint, today we will share with you one of the pipelines, so you may get a flavor of this robust yet simple tool. Without further delay, let's start Azure AutoML, accessible through Data Core Portal. Azure AutoML is the process of automating the time-consuming, iterative tasks of machine learning model development. It allows data scientists, analysts, and developers to build ML models with high scale, efficiency, and productivity, all while sustaining model quality. Data scientists, analysts, and developers across industries can use automated ML to implement machine learning solutions without extensive programming knowledge, save time and resources, leverage data science best practices, provide agile problem solving. DCS AI AutoML's pipeline. Using ML Ops, automate the end-to-end ML lifecycle with Azure Machine Learning and Azure Pipelines. Using pipelines allow you to frequently update models, test new models, and continuously roll out new ML models alongside your other applications and services. To complete the AutoML process, you have to go through these simple steps. Create Workspace, compute, upload dataset, AutoML Experiment, deployment, monitoring, prediction. Let's venture through each of them for a better understanding. To create a workspace, required inputs are explained all through, for your convenience. Workspace name. Enter a unique name that identifies your workspace. In this example, we use DCSWS. Names must be unique across the resource group. Use a name that's easy to recall and to differentiate from workspaces created by others. The workspace name is not case sensitive. Resource group. Use an existing resource group in your subscription, or enter a name to create a new resource group. A resource group holds related resources for an Azure solution. In this example, we use DCS-AML. Subscription. Select the Azure subscription that you want to use. Location. Select the location closest to your users and the data resources to create your workspace. Create compute. A compute target is a designated compute resource or environment, where you will run your training script, or host your service deployment. To create compute cluster, select your existing workspace, which you have created earlier, and select VM size from drop-down menu. Then enter a unique name. Please remember names must be unique across the resource group. Select Cluster Category from drop-down menu to run your training script or host your service deployment. Create DataSet. Automated machine learning supports data that resides on your local desktop or in the cloud, such as Azure Blob Storage. The data can be read into a Pandas data frame or an Azure Machine Learning tabular dataset. Let's know a little more on the datasets, which supports our application. Prerequisites for training data. Data must be in tabular form. Data must be labeled. The value to predict target column must be in the data. To create dataset, select existing workspace and either upload data from local system, or you can fetch data from default Azure Blob Storage. AutoML Experiment. To build ML models, just set up few steps. Environment setup. Data preparation. Experimentation. Deployment. You have several options to configure your automated machine learning experiment. In experiment setup, enter a unique name that identifies your workspace. Unnecessary repetition, names must be unique across the resource group. Pick a scenario from different task parameter values, like classification, regression, and forecasting. Select data from drop-down. You have previously uploaded data for training. Select your target variable, as is a supervised ML. Automated machine learning trains multiple machine learning pipelines. Each pipeline's training is known as an iteration. You can specify a maximum number of iterations, using the iterations parameter. You can specify a maximum time for the run, using the experiment timeout minutes parameter. If you specify neither the iterations, nor the experiment timeout minutes, automated ML keeps running iterations, while it continues to see improvements in the scores. Click Train. Internal preparation, like feature engineering, factorization, encoding etc., takes 10 to 15 minutes to prepare the experiment run. Once internal preparation or internal processes are complete, the running of the experiment takes 2 to 3 minutes more, for each iteration. It chooses the best fit model, by optimizing an accuracy metric. Deployment. Deploy the model, which is a container that will allow to run our model, means the winning model on a specified environment, say Python, and handle incoming requests. Here we have to select an existing experiment, which we have created. Then we will get the information like experiment name, file name, best model name etc. And also get existing workspace details, where we are going to deploy our best model. We have two deployment methods, namely, ACI and AKS. For ACI deployment, we just have to put service name to deploy the best model. For AKS deployment, we have to select existing AKS cluster from the drop-down menu and provide service name for deployment. When you deploy the model, Azure ML Services generates an endpoint, a deployed URL that has been deployed in a container in Azure Cloud, which is now ready to receive HTTP requests from us. Monitoring. Compare model inputs between training and inference, explore model-specific metrics, and provide monitoring and alerts on your ML infrastructure. This information helps you understand how your model is being used. Here you will get summary of the experiments, deployments, workspace, compute, and more. Mainly provides a summary of the available methods to visualize log and metric data stored in Azure Monitor. Prediction. Use the best model to run predictions on the test dataset to predict for the next new dataset. Select experiment name from drop-down menu, which you have used for training. Upload a new dataset, where target variable may or may not be present. Submit to get prediction on new data. Prediction through dashboards. Using interactive and dynamic Power BI dashboards for descriptive, predictive, and prescriptive predictions. Here just an example of customer. Before we conclude, let us quickly share our data course Custom AutoML Native Services, DCS Automated Machine Learning. DCS AI AutoML is a suite of machine learning products that enables limited machine learning expertise to train high-quality models specific to their business needs. Click on AutoML Experiment to create a new experiment for training your model. Providing experiment name, upload your input CSV file. Please ensure that the input file must have target column. Click on Go to start training. Name of the best model is shown along with its accuracy score. A model is considered best model if it has the highest accuracy score. Model's precision, recall and F1 scores are also shown in the leaderboard. Two confusion matrices are displayed, showing count and percent values respectively, for classification scenario. Models R-square score, MAE, and MSE scores, are also shown in the leaderboard. A line plot and a scatter plot is shown, displaying the trend between actual and predicted values during training for regression scenario. Click on Prediction in DCS AutoML home screen to make predictions. Select the experiment name from drop-down menu for which you want to make prediction. Upload data for prediction. Click on Submit button. Prediction is shown in a tabular format. By clicking on Download button, user can download the prediction file. Thanks for watching. For query or feedback, please visit us at www.datacoreautomation.com.